All right, so we're going to solve each quadratic equation using the quadratic formula. All right, so remember, we are dealing with a quadratic equation. What is the general form of a quadratic equation?
X squared plus bx plus c.
Plus c equal 0. All right, so your quadratic equation has that form. And if you were to complete the square, and you have no idea what that is, but if you were to complete the square on this quadratic equation, you would end up with the formula, that quadratic formula. So you would end up with this: x equal negative b, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. You can solve any quadratic equation using the quadratic formula. Can you solve any quadratic equation by factoring? No. First of all, it has to be what? Factorable. It has to be factorable. So for example, I'm going to just write something down. I'm going to ask you, can you solve this by factoring? X squared plus 3x minus 6 equals 0. You can't factor that. So you can't factor that. So there's no way you can be able to use a zero factor property and so forth. So either you're going to solve this by completing the square, which we haven't done yet, or you're going to solve this by using what? Quadratic formula. All right. So the question was, can you solve a quadratic equation always by factoring? The answer is no. But can you solve a quadratic equation using a quadratic formula? The answer is yes. All right, there's quadratic formula. Keep in mind that these variables in here, these letters in here correspond to these coefficients. The coefficient of x squared is a, the coefficient of x is b, and your constant is c. That's what goes into here. Also keep in mind that these numbers that go into here, you better make sure that you have what number on the other side? 0. Okay? All right, so let's solve each by using the quadratic formula. Number 1. Okay, number 1. Suppose we had 4x squared plus 11x minus 20 equals 0. 4x squared plus 11x minus 20 equal 0. First of all, is this in journal form? Yes. Now what I would do next, and if you look at that sheet you picked up, just go through those steps right now, and at some point you wouldn't need those steps anymore because you would know what they are. So it's in journal form, right? Okay. Then it says identify A, B, and C. So what's A in this case? 4. A is the coefficient of x squared. So what's the coefficient of x squared? 4. What is B? 11. And what is C? Not 20. Negative 20. You got to keep the sign. All right, so C is negative 20, not 20. So if you use the wrong sign, then your solutions will be incorrect. So first of all, before you plug A, B, and C into the formula, you better make sure that these are exactly correct. So A is positive 4, B is positive 11, and C is a negative 20. And then all you do now is just plug into your formula. So that's right, plug and chug. So you have your variable is x, and how many solutions do you think you're going to have?
3.
No, not 3. 2. 2. Where do you get 3 from? Okay. Because if you remember when we factored the previous problems, how many solutions were there? 2. Now there's a possibility where you could have 1. We haven't done that, but you can never have 3 because the largest exponent tells you the maximum number of solutions you can have. What's that largest exponent right here? 2. So the maximum you can have is 2. If that was a 5, the maximum you can have is 5. You'll learn that in another in another chapter, excuse me. Okay, so x equal, you got to say x equal. All right, so then look at the formula. It says the opposite of b. First of all, what is b? 11. What's the opposite of that? Negative 11. Plus or minus the square root of. So when you do the work, it's going to say show work. Oh, I need to see this part right here. So negative 11 plus or minus, and then b squared. Yeah, if b was negative, you would need to put that in parentheses. Okay? So to be on the safe side, just go ahead and always put b in parentheses, just to be on the safe side. So be 11 squared minus 4 times a, and everything, notice everything I'm putting in parentheses. A is what? 4 times c, which is negative 20, all over. All over. Make sure you extend this line all the way underneath. Don't let it stop here. You extend it from negative 11 all the way to the end, right? Extend it. All over 2 times a, and what's a? 4. So all you do is just plug in. Now you're going to chug. The next thing you're going to do with this now is you're going to work with the radicand. Remember, the radicand is the part that's underneath the radical. Now, this right here has a name. This is really, this radicand, that b squared minus 4ac, has a name to it. We're going to talk about that next class period. But it is a discriminant. We're going to talk about that next class period. So, you plug and chug. So, we're chugging now. What's on your calculator? What's 11 squared? 121. All right, now always do this first. A negative times a positive times a negative is a negative. A positive. Positive. Negative times a positive times a negative is a positive. All right. And then what's 4 on your calculator? It's 4 times 20. What is it? 320. All over 8. Okay? All right, now on your calculator, what's 121 plus 320? 441? It's a big number, right? Okay, now here's what I want you to do now. Okay, so at this point, am I going to have an imaginary number as my answer? No, because I'm taking the square root of what kind of number? Positive. All right, so we're going to have that to deal with either today or next class period. So this is going to be a real number. It's not going to be a complex number with an imaginary solution. Use your calculator to determine if 441 is a perfect square. So here's, you take your calculator out. Take your calculator out. Do square root. Square root. See the square root button? You say second. You gotta know how to use your calculator. See the square root button's right under the x squared button. See right here? Mm-hmm. It's blue, so you gotta say second this. And then 441. And then press equal. And you get 21. So that means that 441 is a perfect square. Because 21 times 21 is what? 441. So that means this then. That means that this becomes negative 11 plus or minus what? 21 over 8. Notice there's no longer a square root, right? So there's no longer a square root. What that means is that your solutions will be rational. I'm going to write that down. Your solutions are rational. In previous courses, you talked about 2 types of real numbers, rational and irrational. These are rational. This one's going to be rational. And you see why when we get to it, but the square root went away. 441 is a perfect square. The square root of 441 is exactly 21. So I'm going to end up with rational solutions. Since the square root went away, since you no longer have a square root, which means that your solution is going to be rational, I need for you to break it apart. So negative 11 plus 21 over 8. And then negative 11 what? Minus 21 over 8. That's what you got to do next. Now, what's negative 21 plus, I'm sorry, negative 11 plus 21? 10. So that's 10 eighths, right? And over here, that's negative 31 eighths. So y'all agree? No, I'm sorry, 32, excuse me. Negative 32 eighths, right?
Yeah.
The directions will probably say reduce. So 10 eighths becomes what? 5/4. So x equal 5/4. And then negative 32 eighths becomes what improper fraction? Oh, it's just negative 4, right?
Yeah.
Negative 4. Negative 4. Now, those are rational because remember, a rational number, you can write a rational number can be written as a fraction where you have an integer divided by an integer. Is 5 an integer? Yes. Is 4 an integer? Yes. Is negative 4 an integer? Yes. All right, so those are rational numbers. All right, so notice we plugged in chug. I ended up with the square root of 441, so 441 turned out to be a perfect square, which means that when I took the square root of it, I got a whole number. Since I no longer had a square root, I split it apart. And then you go from there. So those are your two solutions. Okay? Now, just to let you know, you see how you have those two solutions that are rational? You remember a while ago I said, is this right here factorable? We said what? No. Okay? And we're going to do one like this in a little while. But you see how we had two rational solutions here? That means this. I could have done this problem by factoring. Right here. I could have done this by factoring, so I want to show you. What are the possibilities for 4x squared? 4x and 4x and x are 2x and 2x, right? Let's try 4x and x. 20. 10, 2, 5, 4. What do you want to try first? 5, 4. All right, now remember last semester you talked about this. You know you cannot put a 4 here. The 4 cannot go here. Because if the 4 goes here, that means you could take out a 4. Which means that the original problem was divisible by what? 4, and it's not because of this 11. So you had that discussion last semester. So where must the 4 go? Here. The 5 must go where? There. Last sign's negative means these signs in here are what? Different. So let's see it. The one that's going to be positive will be this one, and this has to be what? Negative. And check it. What's the outer? 16x. What's the inner? Do I get 11x? Yeah. Set each one equal to 0. So x is going to be what? 5 over 4. Here, x will be what? Which is what you got. Now you're going to learn in the next class period, how you can tell easily, without having to do all this, whether it's factorable or not. And remember a while ago I talked about the discriminant? I mentioned the word discriminant. We'll talk about discriminant next time. All right. But for right now, you always follow the directions. Directions set to do what? Solve by quadratic formula. It's quadratic formula. Okay? All right. Now, let's go back now and do this one right here. This one. I know I can't use factoring for this one, right? Factoring won't work. We tried. Nothing works. So I have to do this one by using the quadratic formula. All right, so let's do that one. Okay, so number 2, we're going to say x squared plus 3x minus 6 equals 0. First of all, you got to make sure it's in general form, and it is. So what is A? 1, good. What is B? 3. And what is C? Negative 6. What is the quadratic formula? X equal what? Negative B plus or minus the square root of B squared minus 4AC all over 2A. So you're just going to plug, and then you're going to chug. So I get equal. What is B, first of all? What's the opposite of that? Okay. Plus or minus the square root of. Put these, the discriminant, the radicand, put that in parentheses. So B is 3, so that'll be 3 in parentheses. What am I doing to that B? Square again. Minus 4 times A, what's A? 1 times C, which is negative 6, all over 2 times A, and A is 1. Just like the previous problem. All right. So I get negative 3 plus or minus the square root of, what's 3 squared? 9. A negative times a positive is a negative. A negative times a negative is a positive. So that's plus what, though? 24. All over 2. Do you compare our steps like last time? Everything's the same. Then remember last time I added those two numbers. What's 9 plus 24? 33? All over 2. All right, so that's where I'm at. So let's compare this with the last one we did. So the last one we did, I was at this point right here, right? So I have this and I have this. So notice we asked ourselves, and this was a big number, so we used our calculator, because I need to first of all determine if this radicand is a perfect square or not. So I used a calculator. It was, and I got this whole number. You don't need a calculator for that one, because ask yourself, is 33 a perfect square? No. Is there a whole number times itself that's 33? Answer, really, what is it? No, right? Okay. Now, there is, I'll say there is a real number times itself that's 33, but there's no whole number times itself that's 33. 6 times 6 is 36, 5 times 5 is 25. Those are your two whole numbers that's closest to it. So 33 is not a perfect square. But then remember, in a previous section, previous problems, we also had to simplify the square root of 33. Is there a perfect square other than 1 that goes into 33? No. So you can't simplify the square root of 33. All right. Now, when we did this one, we said that since square root of 441 was a whole number, we ended up with what kind of solutions? Rational. This square root doesn't go away. So you're going to end up with irrational solutions. So these are irrational solutions. Remember, an irrational number, a rational number is a number that can be written as an integer over an integer. Okay, so I want to remind you about something. The square root of 16, the square root of 32. One of these is rational, one of these is irrational. One of these numbers is a rational number, one of these numbers is an irrational number. Which one do you think is rational? 16. Square root of 16, because the square root of 16 is what? 4. And I can write 4 as 4 over 1, an integer over an integer. Square root of 32, you can't write as an integer, because if you use your calculator, I want you to notice something. Square root of 32 in your calculator, that's a decimal that keeps on going and going and going, and there's no repetition at all. None of those digits, no series of digits repeats. So that's an irrational number. So this is irrational. And this is rational. So since I ended up with a irrational number, I can leave it like this. There's my answer. Now, there are multiple ways, though. You can go and write this, though. But this is fine for me. That's fine. On my math lab, they're going to ask you to separate them using commas. So in my math lab, you're going to say this. Negative 3 plus the square root of 33 all over 2, comma. Negative 3 minus the square root of 33 all over 2. Okay? Now, you got to be careful when you do this in my math lab, though, because you're typing stuff. So in my math lab, if you do this, it's mathematically that's incorrect. Because what you're saying, the only thing you're dividing by 2 is this square root of 33. What else needs to be divided by 2? The negative 3. So when you put this on my math lab, you either need to do one of two things. You need to put this in parentheses like this, because the whole thing has to be divided by 2. Or you can break it down to fractions, and that's probably the better thing to do. Say negative 3 over what? 2 plus square root of 33 over 2. And what's the other? Negative 3 over 2 minus square root of 33 over 2. So just be careful how you write it in the math lab. Right, so
I
they're
didn't realize that Helen was the one that wrote this textbook. So I've been expecting like to go on there into the multimedia library on my math lab and find Miss Helen's videos.
okay.
They are completely non-existent. It's just some goofy guy.
All right.
So there.
Well, I think the author is different.
Yeah, part of the textbook. But
Yeah. All right. So she's talking when she goes to my math lab, and there's some videos it says for you to watch, I guess.
Here, it's the video stage.
Huh?
I think you're out of the video stages. You get
No, wait, he
examples.
does great videos. I watch most of these videos. I watched them last semester too.
Number. All right, let's go to number 3. Okay, number 3. Suppose we had this. What kind of equation is this? Quadratic. Are you gonna tell me what A, B, and C are right now? No. You gotta have it in what form? Standard. Okay, we prefer the word general for this, but hey, you can use standard as well. Because some textbooks do use standard, by the way. So it depends on the textbook whether they use the word general or standard. All right, standard would be bring everything one side set equal to 0. Your book uses the word general. Okay, so we got x squared. Putting these into order, though, what comes next? Minus 8x plus 25 equal 0. All right, what's A? What's B? Negative 8, good. What's C? 25. What's the formula, quadratic formula? Negative B plus or minus B squared minus 4AC all over 2A. All right, so we get, let's plug and chug now. So let's plug. So we get x equal, all right, what's B first of all? Negative 8. So this says I take the opposite of that. So what does that become? Positive 8. Plus or minus the square root of, in parentheses, I put B. What's B? Squared. Minus 4 times A. What's A? 1. And what's C? 25. All over 2 times A. And what's A? 1. So all I did was just plug. Okay, now you're going to chug. 8 plus or minus the square root of, what's a negative 8 times itself?
64.
Positive 64. What's a negative 4 times a positive 1 times a positive 25? A negative. 100?
Yeah.
All over 2 equals 8 plus or minus the square root of a what? No.
46.
No.
Are you combining your like terms?
Yes.
Oh.
Yeah,
Oh,
negative
okay.
36.
Negative 36. You know, the 2 months after you were born, that was one of the things you had to do to get out of the hospital. You had to say, what's 64 minus 100?
Oh, gosh.
What is the square root of negative 36?
6i.
6i. The first, let's compare now. The first problem we had, the first and the second, we were taking the square root of positive numbers, right? The first one, though, turned out to be rational solutions. The second one turned out to be, that was the square root of 33, so that turned out to be what kind of solutions? What kind of solutions are these right here that I'm pointing to? Irrational. So they're irrational solutions. So whenever you're talking about a real number is either rational or what? Irrational. Okay? I is not a real number. So don't tell me that my solutions are real here. They're not. Because it's square root of negative 36. But remember, when we did section 1.4, those are numbers. They're just not real numbers. They're what kind of numbers? Imaginary numbers. All right. But I do know that the square root of negative 36 is 6i. Just like this. Okay? Now, a while ago I said you can stop and give me this as the answer right here. Which is true. Compare that with this. Now remember, these are imaginary solutions now. You can't just say this is your answer, because I know you can do something else to this. They're all divisible by what? 2. So this really becomes, the better answer I want is for you to say 4 what? Plus or minus 3i. That's what I want you to say. Okay? Here, nothing here besides 1 is a common factor. Now, in my math lab, you're going to say this. What are you going to say? 4 plus 3i? 4 minus 3i. Okay? All right, let's do one more with quadratic formula. So we did rational, we did an irrational, and we did imaginary. Yes.
For instance like this, when you're working in like a mathematics field, do they really expect you to break things down like that, like all the way down to like?
Well, it depends on the context. I mean, if this is usually in context, you will probably want it to break it down to its individual parts, because there's a reason why you were doing that. Here, we just want to see if you can solve a quadratic equation. But you do have to understand that there are really 2 solutions here, and those are the 2. But yeah, you would want to break it down to its individual solutions. Now, where are you going to, for the general public, for us, I mean, I never used this in real life. I mean, I use it because we teach it here, but it's just something you need to know how to solve quadratic equations. That does help you with other things, and in terms of understanding how to solve things. But for all of you, once you get out of college algebra, you will have never, unless it's some kind of engineering where you're working a project, on a certain project that involves imaginary roots, it's not going to occur. But, just be able to do it in this class, though. All right, number 4. All you need to do is get a well-rounded education. Okay, number 4. Let's suppose we had this one, 2x squared. Yeah, that's fine. 2x squared equals 1 plus 4x. Okay, what's the first step? Put in what form? General form, okay. When it's descending order, those, what does that become? Equals 0. Okay, direction says use a quadratic formula, so what's A? What's B? And what's C? -1. Okay, so I get x equal the opposite of b, plus or minus the square root of b squared, minus 4ac, all over 2a. All right, what's b? So what's the opposite of b? Positive 4. Plus or minus the square root of b is -4 in parentheses. What do I do to it? Squared. Minus 4 times a is 2, and c is -1. All over 2 times a is 2. Okay? So I get 4 plus or minus the square root of 16. A -4 times 2 times a -1 is what? Positive 8. All over what? 4. Okay, what's 16 plus 8? 22? 24? Okay. All over 4? All right, so that's where I'm at, right? Okay. Now, let's talk about 24. Well, first of all, am I going to get real solutions or imaginary? Real. Because I'm not taking the square root of a negative number. So it'll be real. All right, it's going to be real. So then I'm going to ask myself, is it going to be rational or irrational? If you say rational, you better make sure that 24 is a perfect square. It's not, so it's going to be what? Irrational. So you're still, in your answer, you're going to have a square root, which is what this is saying. But I can simplify the square root of 24, and I need you to. So let's go off to the side and remember how to deal with that. What perfect square besides 1 goes into 24? Huh? 8's not a perfect square. You got to give me a perfect square. What perfect square goes into 24 besides 1? 2 is not a perfect square. 4. 4 times 6. All right, 4 is a perfect square. 4 times 6 goes, so 4 goes into 24. So this is going to be square root of 4 times 6, right? What's the square root of 4? So that becomes 2 square root of 6. So I get 4 plus or minus 2 square root of 6 over 4. All right, now let's talk about how to write this now. Just like when we did the other one, the second one I think it was, we kept the answer. Once we got to that part, we said we're done. For that one, that was true. For this one, it's not. Because you can reduce this. Notice all these parts right here. What are they all divisible by? 2. They're all divisible by 2. Okay, so there are multiple ways of writing this. This is not, if you circle this and that's your final answer, you'll get almost all of your points. But you know, if it's not what I want, I've got to take something away from you. All right, but you'll get most of it. So if you got to that point, you did good. All right, but I need you to recognize that they're all divisible by 2. So the better answer would be this: 4 divided by 2 is 2, plus or minus. This will be 1 square root of 6, right? So that's just square root of 6 all over what? 2. All right, so that'll be your better answer. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 times square root of 6 is square root of 6. 4 divided by 2 is 2. Okay? See, look, this is what you're saying. You're saying this. I'm circling these three things right here, what are they all divisible by?
2.
2. So that's a 2, that's a 1, that's a 2. Okay? So if you need to circle them, go ahead and circle them. Now, again, there are multiple ways of writing this. So another way you could have done this is just to say this. Let's split them as 2 fractions instead. So you could have said 4 divided by 4 plus or minus 2 squared root of 6 divided by what? 4. But then you got to reduce. What's 4 divided by 4? 1 plus or minus, and this becomes square root of 6 over 2. 2 fourths is 1/2, right? So that's another way you can write these answers. Another way is to split them apart. So you'd say 2. There's all kind of ways, right? 2 plus the square root of 6 over 2, comma, and what's the other one? 2 minus square root of 6 over 2. All kinds of ways to write these answers, write these solutions. Okay? But I do need for you to recognize that when you get to that point that you knew you had to do something more to it, because these 3 things are all divisible by 2. Now, here's a mistake people make. All right, so let's suppose you got to this point here. All right, you got to that point here, and you did this. Okay, so you got to this point. I'm just telling you kind of mistake that some of you will make if you're not careful. So you'll say, all right, I'm circling these, so I know they're all divisible by 2, right? All right, so then you're going to say 2 plus or minus square root of 6 over 2. Okay? Then you're going to go, you're not going to be careful, and you go a little bit further, and you're going to say this. Oh, but these divide out. And so I get 1 plus or minus square root of 6. That's what he's going to say. And if it's like 10 points, I'll probably take off a half. And then you're going to be very upset with me.
Very.
Because you're going to say, I had the answer. Yeah, but you went further with an incorrect mathematical procedure. That's not correct. Why do y'all think this going from here to here is not correct? Because you see this 2 down here? The 2 is being divided into 2 things. This one and what? That one. So when you cross this one out, you forgot that the square root of 6 is also being divided by what? 2, which is what you saw here. All right. So you got to be careful. You need to be careful when you're going from something to the next thing that you write. Okay. So don't make a mistake. You can't. This is not true. Okay. That does become a mistake. It's kind of like when you had this in a previous course. Let's say you had 4 plus 3x divided by 2. Stop there. Just stop there. There's nothing else you can do. Now, if you want to go further, you can. You can say 4 divided by 2 is what? 2. Plus, and then 3x has to also be divided by 2, right? But it is incorrect to say this. You understand? Because you're dividing this 2 into this one only, but it also has to be divided into what? That one as well. Okay? So be careful. I just need to bring that up because some of you are going to do this. And you're going to be upset. All right, so let me just kind of give you the worksheet that goes with that.